Hey everybody, it's Dr. Wood, and today we're going to be talking about Chapter 9. We're covering non-parenteral dose calculations, and this is mostly going to be focusing on oral meds, but we'll see it can apply to maybe a few other types as well as we kind of go through this. So just a few basic rules to kind of help you out through this process here is one, always make sure you're using the same units of measure, so that way you're getting the proper conversions done. If you're mixing and matching your units there, it could lead to some incorrect solutions. It's always helpful to work out your math on paper, just kind of double check yourself and to make sure you follow your units and you're crossing out things appropriately. And then if a calculation gives you something that you don't expect, it's always good to recheck your math just to make sure everything was done appropriately there, okay? And then when you're looking at the actual prescription itself, read the order again just to make sure you're calculating for the actual dosage requested. Sometimes it's easy to kind of blow through those and say, okay, I know what they're talking about, I know what they want, and maybe you misread it the first time. So it's always good to go back and double check the actual prescription orders. So some other things to know when you're dealing with non-parenteral dosage guidelines is that typically when you're dealing with things like capsules, when you're dealing with things like enteric-coated products, if you're dealing with the extended release products, don't mess with them. Don't crush them. Don't chew them. Don't divide them. Don't do anything else like that. You tend to break kind of the special characteristics of the tablet when you do that, or the dosage form when you do that. So as an example, if you have a sustained release product and you chew that up, that makes all the medication that should be released over 24 hours release all at one time, right? So that can lead to some pretty severe toxicity. For instance, if you have an enteric coated tablet that is designed to prevent stomach acid from destroying the drug, well, if I chew that up and then swallow it, well, the stomach acid has access to all that drug and can then destroy it, right? Other things to note is that tablets that are not scored generally are not intended to be divided. However, if you do have a scoring down the tablet or that marking that allows you to snap it in half, that is okay to be broken in half. There's no problem with that. Other things to consider are things like buccal or sublingual tablets. Typically, you don't want to swallow those or crush them or chew them, mainly because that can affect how well it gets absorbed. So just kind of keep them underneath the tongue or in the cheek, and that's fine. And then always double check yourself. There's really good online resources to find do not crush or chew list, and that will tell you which medications you don't want to mess with. Otherwise, it could lead to some of these problems that we already mentioned. So when you're determining how to dose a medication for a patient, there's a couple different things we're going to be looking at. First off, what is the medication that we have on hand? What's the dosage form that we have available? Do we have 25 milligram tablets, 50 milligram tablets? That's going to be our dose available. The abbreviation is DA here. Next up, we're going to be looking at trying to determine the physician's order or the provider's order for the dose wanted. This stands for dose ordered here, or sometimes it's considered or abbreviated as DD for desired dose. And then we're going to be identifying the form of the medication available to supply that dose, which is usually going to be based off of the DA or what's actually available to us. And then we're going to find the final calculation here is going to be giving us the dose to give to the patient. Okay. Now, again, make sure all of the measurements are in the same system, and convert as necessary if you need to. If you need to convert from milligrams to grams or from pounds to kilograms, whatever the case may be, make sure to do those conversions beforehand. Now, there's three different ways of calculating the doses here, and we'll look at each of these with a few different examples, including ratios and proportions. We use a formula method and this dimensional analysis. These are all going to be three different ways to get the same exact answers as we're going to see. Okay, and you need 4 parts to answer these questions. You need the dose ordered, you need the dosage available, the dosage form, and the dose to give. Most of the time, we're going to be looking for this as our final answer, is that DG. So using the ratio and proportion means of finding our dosage, what we're going to do is get a first set of comparisons found on the stock medication. So basically, on one side of the equation, we're going to have our dosage available and then the dosage form, so DA and DF. And then on the other side of the equation is going to be basically what the provider has ordered on the script. So it'll be the dose ordered and then the dose to be given. And this is generally what we're trying to find is a DG. So to look at it as a ratio, you can see the dosage available to the dosage form, DF, equal to the dose ordered to the dose to be given. So let's do an example of this. Let's look at the medication glucophage or metformin. This is a drug we use for diabetes pretty frequently. The dose ordered is 850 milligrams q-day by mouth with meal. And then the dosage available to us is a glucophage 850 milligram tablet. And again, this may seem like it's very straightforward off the bat, but it can get more complicated, as we'll see with some of the assignments and the quizzes. So the first thing we have to ask ourselves, are the units in the same measurement? Yes, they are. Look, we're dealing with milligrams and milligrams. We're not trying to compare units to micrograms, etc. So yes, the units are all in the same measurement, so we're good to go. So again, the question we're asking for is, what is this DG? What is the actual dose we're giving, or in this case, the number of tablets we're going to be administering? So by setting up the setting up the ratios here, we're going to have 850 milligrams as our dosage available in one tablet, which is the DF, to 850 milligrams of our dose ordered to the number of tablets that we're going to be giving here. And X stands for that dose to be given. So when you rearrange it, you're going to find that 850 is to 1 as 850 is to X. Or basically, by turning it out, 850x equals 850, divide both sides by 850, and boom, you have x equals 1. So the desired dose, the dose to be given, DG, is 1 tablet daily. What if we did this with a liquid medication? Let's use sulfamethoxazole, which is a type of antibiotic. It's usually supplied as a 1 gram per 10 ml solution, and the doctor orders sulfamethoxazole 2 grams. Well, how many milliliters would be administered? How many teaspoons would be given, right? So we can do that conversion too. So let's say here we're going to set it up as a proportion. So 1 gram per 10 mLs and 2 grams per X mL. So we're going to be solving for X here. Or if you want to set it up as one of these ratios, you can see this here. Basically by rearranging it, we can see that 1 times X equals 2 times 10. 1X equals 20. And so there you go. X is going to be 20 mLs you're administering. So 20 mLs for that dose to be given. Now, what if I wanted to convert that over to the number of teaspoons I would have to give? Well, I can do the same thing all over again. I can take 1 teaspoon to 5 mLs, which is something you should already know, to X teaspoons over 20 mLs. So basically by doing the same thing here, we can end up finding out that X equals 4 teaspoons, okay? Which makes sense. 20 mLs divided by 5 mLs per teaspoon gives you 4 teaspoons. Pretty straightforward. Another way we can do this is with the formula method, where we're going to rearrange this and automatically solve for the dose to be given here, where basically we're going to take the dosage ordered divided by the dosage available times the quantity or the form, okay, the DF here. And so when you look at this as an abbreviation, it's DO over DA times the quantity equals the dose to be given. So let's do this again with our glucophage example. We have our 850 milligrams again we're giving and what we have available to us. So setting this up in the equation, so our DO of 850 milligrams over our dose available of 850 milligrams times our quantity of 1 tablet equals X tablet DG. And again, 850 divided by 850 is 1. So you have 1 times 1 equals X. In this case here, 1 tablet. So the desired dose would still be 1 tablet daily. Just another way to rearrange the equation to give us the same answer essentially. You can do the same thing in the sulfamethoxazole example we had before, where here we have our DO of 2 grams, the dose available is 1 gram, and then this is per 10 mLs, right? So we have 1 gram per 10 mLs is our DF, and this is going to equal how many ever mLs we want to administer here. So our grams cancel out, so you have 2 times 10, which is going to equal out to be 20. So X equals 20 mLs here. And again, same thing for the teaspoons. To figure that out, basically convert this over, and it's still 4 teaspoons. One last way you could do it is what we call with dimensional analysis, and basically it's setting it up as kind of a linear equation for the calculations that allows for conversion between measurement systems that has kind of a series of fractions or series of ratios. And again, this is a process of writing out fractional factors that include all the conversions that we need to do. Sounds a little confusing, but I'll show you what that means. Basically, on the left side of the equation is the variable x we're trying to solve for, and on the right side will be the equation of all the factors we're looking at. And so the starting factor is going to be the dose ordered, and you're going to find that the numerator will show the measurement system of the dose ordered, and then we continue to add factors until basically the linear equations cancel out until all we have left over is our dose to be given. So using our glucophage example once again, we can see here by setting up as X, which is going to be our dose to be given, equals 850 milligrams, which is the dose ordered over 1. So you always set it up over 1 just to begin with. So that's the initial fraction. And you're going to multiply that by 1 tab as the dose available over 850 milligrams. So what you see here is that the 850s will then cancel each other out, and you end up getting 1 over 1, which is basically 1, times 1 tab. And so X equals out to be 1 tab. Pretty straightforward. If we do that with the sulfamethoxazole example, let's say here we have X is equal to 2 grams over just 1. Again, 2 grams was the dose that was ordered by the prescriber, and that's going to be over 10 mLs to 1 gram. Now again, you set it up such that the grams can cancel each other's out. And then here you do the next part of the equation. You're already figuring out for the number of teaspoons you need to administer. Here you have 1 teaspoon is equal to 5 mLs, so the mLs will then cancel at this point. So you can kind of go through, cancel out grams, cancel out mLs, and you figure out that now you have 4 teaspoons left over. So 4 teaspoons would be the dose to administer to that patient. Moving on, how we reconstitute medications is really important. When we say reconstitute, it means taking it from a powder and putting it back into a liquid formulation. You need to do that because patients can't very easily just take powders by themselves. And so based on how much volume you reconstitute that powder with will dictate the concentration that you get. So as an example here we have a label for the drug Zithromax or azithromycin. It's a very common antibiotic used for a lot of upper respiratory tract infections, for pneumonias and things like that. You notice here that 200 milligrams per 5 mLs, this is when it's finally reconstituted. If you notice here, it's a 30 ml bottle and it contains 1200 milligrams of azithromycin in total, which actually makes sense because if you took 200 milligrams per 5 mLs and figure out, well, how many 5 ml increments do you have here? Well, 30 divided by 5 is 6. 200 milligrams times 6 portions equals 1200 milligrams. And so that makes sense that total amount in the bottle is 1200 milligrams. But if you look here, you notice how much we actually have to administer. So 15 mLs of water to the bottle. So that's how much we're going to put into that bottle to reconstitute it to get that final concentration of 200 milligrams per 5 mLs. Now, you're going to find that depending on how much water you put in, you actually get a different concentration. And so you always want to make sure you document this to make sure that you have all the information appropriate and that other people who come along after you know what concentration you have and how much was given, etc. So as an example, of looking at the total amount of the Zithromax that we have here, looking at the different water amounts that we could add to it, you'll find out that we get the total volume after we reconstitute. However, looking at this, you're going to find you have very different concentrations of the drug here. So 100 milligrams per 5 ml versus 200 for most of the other ones here. Most of this will be dictated based off the bottle size. So as an example, you'd have a 1200 milligram size bottle of the drug or 900 or 600. But basically, depending on how much drug is originally in that bottle and how much water you add to it, that will give you your concentration. Now, we have a lot of special calculations that we'll do for people who are not what we consider to be the typical adult patient. That includes a lot of patients at the extremes of age, including infants, geriatrics, or adults who maybe don't fit the normals of height and weight typically. We see this quite frequently for a lot of morbidly obese patients where you have to do special dosing calculations to make sure they don't get too much medication. The most common place that I do this is going to be when I'm dealing with pediatric chemotherapy for kids with cancer, essentially. We have to use very special calculations to make sure we don't give them too much to cause a lot of toxicity. So one way we can do that is to use body surface area. And so we've seen weight-based dosing before, where you just dose it based off of a person's weight. But let's also factor in their height, right? So this is how we come up with BSA. It looks at the patient's height and weight, and using a nomogram, it'll give us a certain body surface area. We'll see here on the next slide, the nomogram we have on the left side is going to be height, and on the right side is going to be weight. Both centimeters and inches and pounds and kilograms are going to be present. It's important to make sure you know which side you're using depending on the measurements you get from your patient. But essentially what you're going to do, say for an adult patient, is you're going to be looking at saying, let's say you start off at say so many inches. Let's say a person is, say 70 inches. And then you also will line that up with their weight. So you say you'd start here, 70 inches, and then you look at their weight in pounds. Let's say they weigh 160 pounds. And then based off of that, you would draw a straight line. Now the line I'm going to draw is not very good, but you can see here how I would draw that through. And the patient would have roughly a BSA of 1.9. Now this is not super exact. You'd want to use something like a ruler or something like that to get the correct values there. But this is one way to do it. There's plenty of calculations that are out there as well. For instance, for pediatrics, I use a very specific calculation that is standard to pediatrics. Depending on where you work, you might find other calculations being used here. But this is just one way to do it. Now, when we're trying to determine a patient's BSA, we're going to compare that to sort of the prototypical adult patient who weighs roughly 140 pounds and has a BSA of 1.7 meters squared. Meter squared is going to be the unit of body surface area. We'll actually compare the patient's BSA to that standard adult BSA, and then by getting that proportion, we're going to be able to get the desired dose that we're looking for. And I'll show you what that looks like in a second. But let's say we have a child that weighs 55 pounds and is 85 centimeters tall. Basically, you would mark off their height on the first column on the left side of that nomogram. You'd find and mark off their weight in the second column, and then use that ruler to align the marks, and you get the BSA. And let's say it comes out to be 0.82 meters squared. So, in another example, let's say we have a kid that weighs 70 pounds and is 45 inches tall. The provider orders albuterol based off of the body surface area of the patient. Now, let's say a normal adult dose would be 4 milligrams of albuterol. This is a medication used typically for asthma. Usually it's given as an inhaler, but sometimes it can be given as a liquid medication here. And so based off of this, we would see that we want to compare the patient's BSA in meters square, divide that by 1.7, which is sort of that normal adult we were talking about, and then multiply that proportion by the adult dose. And this would give us what our new desired dose would be. In this case here, a kid with these stats would end up being 1.2 meters squared. We take that 1.2 meters squared, which is our patient's BSA, divide that by 1.7 meters squared, which is that typical adult, and then get this proportion and then multiply that by 4. What you end up getting is an answer of 2.8 milligrams, or for our purposes, we'll just round up to 3 milligrams. So the albuterol syrup that we have is available in 2 milligram per 5 ml concentration. So now we can figure out how much we actually have to administer to that patient here to get the right dose. Let's say we have 3 milligrams, which is the dose ordered. Divide that by 2 milligrams, which is our dose available, and that's per 5 mLs, right? And we see that it's 2 milligrams per 5 mLs. We multiply that through, and we end up getting 7.5 mLs total. So that's the dose we would need to get to our patient. Or if you want to convert that back into teaspoons, you would just say, 7.5 divided by 5, and you get 1.5 teaspoons. You can, as I mentioned before, use milligram per kilogram dosing. This is super common in pediatrics that we do all the time. And basically what we're going to do is if the patient has a weight in pounds, we want to convert that over to kilograms. So we would just take the patient's weight and set up a normal sort of proportion here. So we use that conversion of 2.2 pounds to 1 kilogram. And when you're looking at the dosing, frequently when you look it up, you'll see it's expressed as milligrams per kilogram per the frequency, whether it's daily or BID or whatever the case may be. Really what this is saying is that slash sign, well, it normally means divide by, in most other instances here, what it means is to actually multiply it through. So what we would do is get the patient's dose in milligrams, multiply it by the number of kilograms the patient is, and then that frequency, and that'll give us our administration dose. So we'll go over some examples of that in the quizzes and the assignment. You'll kind of see what that looks like. Now, there are other non-parenteral medications we may talk about as the class progresses, but you'll see they all have their sort of individual, unique sort of dosing, whether it be ophthalmic medications or otic medications. They're given as drops. We'll have nasal sprays and inhalation solutions. Those are all dosed a little differently. And then topical products like lotions and creams, very frequently they don't have a specific dose. It may just say apply to affected area. Depending on how big that area is going to be determining your dose. So again, a lot of different ways to do this, but we kind of covered the most common oral sort of dosing calculations. If you have any questions, let me know, and I'll talk to you soon. Thanks a lot. Bye.